Okay, we're in section 24. We'll do the examples. These examples pertain to the notes, the lecture we just gave you. I realize for a lot of students, this stuff is really complicated. I do want to point out the skills that you've acquired in math 100, 119, and 120 are going to be helpful in being able to do these problems, but these problems do involve calculus. So I'm going to go to the whiteboard and I'll do one problem at a time. And then after I do the problems, I'm going to recommend again what the procedures are for you to follow. So new share, I'm going to do the my iPad, my whiteboard. And one problem at a time. So it says, it does say use the first derivative test, by the way. But someone could say, I think I can do this without using calculus. And I'm not saying you can't. It's definitely like looking at it. I know this is a conic section, and what conic section is it? It's a parabola. So I just want to briefly go through that with you. But again, I want to emphasize, going back to what you've done maybe in Math 100, it's fine, but they do say use the first derivative test. But anyway, let's go through back what you've done in Math 100. This would be x squared plus 100. Let's see, that would be minus 20x plus x squared. Wow, it's complicated. 2x squared. Let's see, minus 20x plus 100. Wow, it's a lot of work. 2x squared minus 10x plus 50. Boy, I got to factor that, don't I? What do you get over there? Excuse me. You get 2x and x. This is what you would have done in Math 100, by the way. Probably 5 and 10, right? And then they'd ask you to graph it. Oh boy, that's going to be a lot of work, isn't it? So I got x-intercepts at 5 and 10. And this thing opens up like this here. And the minimal point over here would be there. That would be between 5 and 10. Let me see if I did something wrong here. Use the first derivative, get these graphs at minimum. X squared. 100 minus 20x plus x squared. 2x squared minus 20x, 100. Oh yeah, I see the problem now. I'm sorry about that. I did the wrong factoring. And I'm going to have to erase it. But there's a point to this. The point is going backwards what you did in Math 100 is kind of counterproductive. There's a complication over here. And I didn't, it's a bad graph. And I want to point out, it's also a bad factoring. It was wishful thinking on my part. That doesn't factor like that. I mean, that may give you plus 50, but it doesn't give you minus 10 in the middle. So I'm going to say this is probably not a good idea. All right, let me go back over it though. And I want to point out, well, you know what? I can still go back to Math 100. And how do you get the vertex in this guy over here? Well, I'm going to remind you, Math 100, what you did is minus b. It's going to be 20 over twice a, which would be 4. And then you do f of that number. Well, 20 divided by 4 is what? That's 5, right? So where does that minimum occur? It occurs at, let's see, 5, f of 5. And what's f of 5? Well, I think I can do that. That's 25 plus 25, which is 50. All right. So that's where the minimum occurs. All right. But anyway, they didn't say to do that. It's a minimum, by the way. This is where the minimum occurs. What did they say to do? Use calculus. So I'm not going to say I wasted time doing that, but I realize it's a level of complication I don't want to deal with. So I want to go to calculus now, and I'm going to write this down. So let's write this down. F of x equals x squared plus 10 minus x squared. I'm going to do a derivative. That's 2x plus 2 times 10 minus x to the first power times of the inside, which is minus 1. That doesn't look too bad. And then what do I get to do? Well, the domain of this thing is all real numbers. So I'm looking for a critical number. And a critical number here is where this thing would become 0 because it's defined everywhere. So I'm going to write this down. It's when 2x equals 2 times 10 minus x. Again, this becomes 0 when those two things produces 0. Now that would presume when 2x equals 2 times 10 minus x. That means x equals 10 minus x. Divide both sides by 2. What do you get? 2x equals 10 or x equals 5. So I know that the derivative f prime at 5 is equal to 0. I put my derivative line down. This is f prime. I put my 0 down, which is at 5. I take a number to the left and right. And by the way, we're taking the derivative now. If we go to the right of 5, like I took a number like 10, what would I get? That's to the right of 5, by the way. That would be, well, gee, if I took 10, that would be easy. That's positive. What does that say? The function's increasing there. F is increasing. Now, if I take a number below 5, like, 0, what would I get? Gee, that would be negative. Where'd you learn sign analysis in Math 119? We're doing sign analysis up here, by the way. So what do I know over here? Just look at my picture. I know this is a minimum. So my minimum occurs at 5. All right. Let's go back over here. And it says, we'll discuss this in class. It says the critical number C equals 5. I got that part. A global minimum occurs at x equals 5. I did mention that to you over here. And again, in the picture from the pre-calculus, I know that as well. It's increasing on 5 to infinity. That's indicated over here. And it's decreasing on minus infinity to 5. And that's indicated over here. I'll put down decreasing, by the way. All right. Let's go to the next question. And next question is, no, I couldn't have done this in Math 100 or in 119 or 120 for that matter. But I know the domain here is greater than 0. All right. So what I'm going to do, I'm going to answer the question. And they want me to get the min maxes in the problem if I can do it. Well, I'm going to, put down the derivative now. So what's going to be f prime? That's going to be 5 halves. X, I take away 1, right? That's 3 halves, isn't it? Minus 2x. Well, here comes my problem. That's, on that interval from x greater than 0, this is always defined. My concern is it ever equal to 0? So I'm going to write that down for, is it ever equal to 0? So I get something like this. Let me see if I can solve that. That's 5x to the 3 halves equals 4x. I would probably square both sides. I would get 25x cubed equals 16x squared. And then I would probably subtract 16x squared from both sides. Yeah, you need algebra skills to do problems like this. And then what I do, I'd probably factor out an x squared. And what would you get? Let's take a look. You would get 25x minus 16 equals 0. All right, I got to stop for my advertisement. Yeah, I make mistakes sometimes, and I know that. What are the critical numbers here? Some people might want to say 0, but 0 is not in the domain of the problem. So the only other possibility is, does 25x minus 16 ever equal 0? And it does. So the critical number over here would be 16/25, which is definitely on the interval. Now, what do I got to do? I got to analyze the derivative. There's only one 0. And I'm going above 0. All right. So I want to pick a nice, easy test point. So someone says, what's the derivative? I can't remember. It's right up here. So I'm going to say, what's a nice, easy test point over here? I'm going to say 1. If you plug in 1, what would you get? You get 5 halves minus 2. Well, 5 halves is 2.5, right? And 2.5 minus 2 is a positive number, right? What does that mean? Increasing. All right, let's take a number below 1. And someone says, what's a good number below 1? I'm actually going to say, I'm sorry, below 16/25. A number below 16/25, I'm going to say 1/25. More difficult, but I got to plug it in. And we're going to plug into the derivative. So f prime 1/25. What's it going to give me? 5 halves. What's the square root of 1/25? 1/5. But I'm cubing it. So it's 1 over 125 minus, well, again, I'm plugging in 1/25, right? So it's 2 times 1/25 is 2/25. What do you get over here? 1 over, let's see, that would be 50, right? because 5 goes into 25, 25 times, so 2 times 25 is 50, minus 2 over 25. So what do you get over there? Common over 50. Yeah, I know it's arithmetic. That would be 1 minus 4, which is minus 3/50, which I know is a negative number. So it's decreasing here. And what do I know I got over here? I got a minimum. All right, let's take a look, see if we did it. I make mistakes all the time, by the way. And if I make a mistake, I'm going to erase it and do it again. It's that simple. All right, so let's take a look at it. And it says the critical number 16/20, 16/25. I said that. Did I say that it's a global minimum at 16/25? Let me go. I'm sorry. Let me go for that. Yep, minimum right over here. Let's keep going. And did I say it's increasing from 16/25 to infinity? I forgot to write it down. Increasing. Yep, I did say that. And did I say it's decreasing from 0 to 16/25? Yep, I said that too. Pretty good. All right, let's go next page. And that's number 3, right? Let's take a look at it. So the domain of this guy, use the first order test to find the minimum maximum of f, indicate if these are absolute. Let me see if they said that in the other problems too, that the absolutes. They did. Let me go over that again. Maybe I should have mentioned that. By the way, the parabola, definitely an absolute minimum. This guy over here, how to know what's absolute minimum? Just look at it. You got, if it's decreasing, increasing, there's no other possibility than that being an absolute minimum. Sorry about that. I didn't mention that before. But let's keep going. And I got to worry about this guy over here. So, whoops, am I out of juice? I'm getting close. I got to plug it in. I'm getting close to this thing dying on me. And it happens sometimes I forget to plug these things in. And then all of a sudden it dies on me, or it says I can't go on anymore. And I'm really at the bare bones of my energy here. All right. Sorry about that. So let's write the domain down. It's going to be all real numbers. However, x can't be plus or minus the root of 3 because we have division by 0. So the next thing I want to do is I want to do the derivative. All right, I'll put this over here for you. Square the bottom. Bring the bottom to the top. Times the derivative of the top, which is going to be 3x squared minus the top times the derivative of the bottom, which is 2x. Now, someone's going to say, do I have to do what you're going to do next, which is simplify? It is in your interest to simplify. So it's going to be x squared minus 3 squared on bottom. And on top, I'm actually going to factor out an x squared. And let's see what we end up with. So you would get 3x squared minus 9. Make sure I did that right. 3x squared. Yep, I did that right. And then you'd get, I factor out an x squared, so you get minus 2x squared. I'm going to keep simplifying it. The problem would work for a lot of people is after they do the work, they don't know why they've done it. So that's going to be x squared minus 9. And on bottom, you get x squared minus 3 squared, right? This is the derivative. All right, let me take a look. All right. And I got to put this down. Now there's 2 numbers that need to be removed from this line immediately because they're not in the domain of the problem. And what are those 2 points? It's actually plus or minus the root of 3. What are my critical numbers? One is 0. That's where the top becomes 0. And the other one's plus or minus 3. I'll put this over here. Now someone would say, I don't think you really spaced those properly. It's not important. What's important? You know you have a tremendous number of intervals to test out, which is something that you did in math 119. You did what's called interval analysis for inequality. So we're going to do the same exact thing. So someone says, what points you're going to pick? I'm going to write them down for you. -4. Over there, I'm going to pick 4. What number I'm going to pick over here? Well, I'm going to say 1. I'm going to say -1. What number I'm going to pick here? You notice I'm picking numbers that I like. You may say, I don't like your numbers. I'm going to pick my numbers. We're going to encourage it. You pick the numbers you like. What's number between √3 and 3 that I like? 2. You notice I like integers, by the way, right? -2. Let's test it one at a time. What do I notice, though? I want to get this across to you. The bottom is always positive. No matter what number I choose, because I'd never choose -√3 or 3. It's not in the demanded problem. The bottom's always positive. How do I know it's a square? What else do I know? This is always positive. No matter what numbers I choose on that interval, it's always going to be positive. I would never pick those numbers that are circled though. Here's my problem over here. My analysis really boils down to looking at x² - 9, one at a time. If you tried -4, what would you get? A positive number, right? If you tried 4, what would you get? A positive number. You notice I'm picking things I like to pick. I'm going to pick 1 now. What would you get? Negative number. Let's say you pose -1. What would you get? You would get, well, -1 would give you a negative number, right? All right, let's keep going. Let's say you chose 2. You still get a negative number. Let's say you chose -2. You get a negative number. And this might seem odd to you, but what do I see over here? I see it increasing. I see it decreasing. I see it decreasing. I see it decreasing. I see it decreasing. This might be upsetting for you. And what do I see over here? I see it increasing. All right. Now, what I want to do, I want to go back to what you learned in pre-calculus for this problem over here. And so, why do you go back to that? It's important you have a background. Otherwise, everything is going to be sort of isolated and you can't do anything. All right. So what I want to do is I'm going to talk about how I graph this problem out for you. And let me write this down for you. So in Math 119, if you were given something like this, I'm going to do the 119 sketch that you did in 119. You would have put this down, a picture. You would have put asymptotes down. The asymptotes would be this. X equals √3. X equals -√3. You would have done a long division. I'll do that for you. So it's going to be x² -3. And why is that? The degree at the top is 1 more than the bottom. What would you give there? X. That would give you x³ -3x. Let's make sure I did that right. X times x is x³. Yeah, and then you subtract, you get 3x, and I'm done. So what do you get? x³ over x² -3 is the same thing as x plus 3x over x² -3. Now, what do I know about that? I know I have a slant asymptote, and the slant asymptote is y equals x. It's this thing right over here. I'll put that in, and that would be y equals x. Now, again, a lot of people question is, why do you do this? I do this to remind you that it's important. Your past is important. What am I going to do now? I'm going to kind of, put the picture in. And as I do this picture over here, again, your mileage may vary, but, I'm going to say there's a point that I'm interested in. The only point I really have that's interesting to me is 0, 0. All right. And what I'm going to do is I'm going to talk about what happens after √3. Now, what happens after √3 is there's a sign of the problem. Like if you pick a number like 5 and plug it in, it will be positive. So I'm going to say it looks something like this over here. All right. Now I want to go below -√3. I can take like a number like -5, and you would get a negative number. So I'm going to say it looks something like this over here. And again, we're doing what you did in Math 119. All right. Now let's go between 0 and √3, and I pick 1. And what would you get? Well, if I did that, the top would be positive. The bottom would be, let's see, if I pick one negative. So I get something that looks like this over here. And again, I'm just saying it's a rough ballpark. And then if you pick a number between -√3 and 0, like -1, plugged it in, you'd get a positive. So something like this over here. All right. So someone could say, what does this really tell me? It tells me I have this, which is a local max. And it tells me I have something over here, which is a local min. Someone says, why is it not global? I have points below that all over the place. Why is that not a local max? I got points above that all over the place. Now, what are these guys? All right, this is the whole reason for me doing that Math 119 pre-calc sketch. Okay, let's go over this. Where's the local min? Right here at 3. So I'm going to put this over here. This local min, it's a local min occurs at 3, f of 3. We'll look at the key later. Where's the local max? It's at -3. It's right over here. Let's go back over here. The local max is at -3 f of -3. All right, let's go the thing and see how we did. And certainly, what does it say? Critical numbers are 0 and plus or minus √3. We have a local maximum at -3 that's indicated right here. It goes on to say we have a local minimum at 3 that's written over here. It says it's increasing. I think I have that written over here, by the way. It's increasing from -infinity to -3. I got that over there. And from 3 to infinity, I got that written over there. And it's decreasing from, let's see, -3 to √3. Again, I'm just looking at my key, by the way. -3 to 0, 0 to √3, and √3 to 3. By the way, it's an interesting concept over here, but we're just using a derivative test for increasing. By the way, you may say to yourself, I think I want to include a net point over here. We're just going to say where the derivative is negative, it's increasing, decreasing, where it's positive, it's increasing. All right, that's all we're doing. All right. So that's done. Again, I'm not saying it's easy. I'm just saying it's done. Oh boy, this could be a tough one. And why is that? It's trigonometry. Use the first derivative to find the minimum maximum of f and indicate if these are absolute, global, or relative. Ah, boy, I got to do another problem now. So let's write this down. And the domain of this guy over here. Let's go back to black ink. The domain of this problem over here is all real numbers. All right. Now, I realize it's difficult, but I got to get its derivative, and then I got to analyze the derivative. So I'm seeing cosine x. Let's see, minus √3 sine x. All right. This has no troubles as far as being undefined. I wonder, is it ever equal to 0, though? So I'm going to write that down. For f prime of x to be equal to 0, it basically says that the cosine of x would have to equal √3 sine of x. Well, it brings me back to Math 120, how to solve that equation. And what I'm going to do is I'm going to divide both sides by cosine and by √3, and I would get tangent of x equals 1 over √3. So I'm starting to realize this is really not a bad problem. And the reason that I know how to solve that equation, and 1 over √3 would be the reference of 30 degrees. So the reference angle would be 30 degrees. Now 30 degrees, I want to point out, I really can't use that. That's pi over 6, right? So x will equal pi over 6 plus, what's the interval length of repetition for the tangent curve? It's going to be pi. So pi k. Now, I think you've probably heard me say a number of times that I'm not a native speaker of radian, but I am a native speaker of degrees. And the reason I want to talk about that, not that I want to write those as an answer down. I can't speak in that language in mathematics, but this is 30 degrees plus 180 degrees k. Right, now I'm going to put my number line down, and there's a problem with this now. There's going to be an infinite number of points to put down. What's my first one going to be? Pi over 6. What's pi over 6? 30 degrees. What's the next one going to be? 210 degrees. Right? Now, what's that going to be? Well, I'm going to write this a little differently. I'm going to write it as 6 pi over 6. So this is going to be 7 pi over 6. You get the idea? So I'm going to say I could keep doing this all day long. How's it going up? It's going up by 6. So you want to say 6, 1, 7, 13. What's the angle going up by? Well, it's going by 180 degrees, right? So that's pretty easy to do. So 180, that would be 3. What would that give you? 3 what? 3, 180, 390, right? So let's take some test points. And by the way, I'm not saying I'm done writing down points, but I want to get a pattern. I think it's going to be bouncing around, bouncing around, bouncing around. That's what trig functions do, right? Where do I analyze this guy? Well, analyze it over here. My derivative. So what's a good number between 30 and 210? I'm going to say 90 degrees would be good. Right? What number would you get? Well, if I plug in 90 degrees in this equation over here, what would I get? I get a negative number. So that's decreasing, right? Now let's go to the next interval. And what's a good number between 210 and 390? I'm going to say 360. Whoops, sorry about that. I'm going to say 360 degrees. All right, but mistakes happen, by the way. The reason I say that, everyone makes mistakes. Don't be discouraged when you make mistakes. Be encouraged that you can try again and again and again as many times as you like. All right, so let's say 360. What would you get? That'd be positive. I think I get an idea over here that this thing's going to be up, down, up, down, up, down, up, down. All right, I'm going to put something like this. And I'm going to write this down now. All right, so I'm going to say up, down. And I'm going to look at these guys over here. And what are these things over here? They're maximums. Let's write it down. Where does my maximum occur? Let's write this down. The maximums would occur at x equals, let's write, be very careful now. The first one I'm looking at is pi over 6. We'll look at our key later. Plus, well, you know what? If you look at this thing over here, it goes up. And what's it going to hit? 13 pi over 6. Well, how much would that be? That would be 12 pi over 6, which would be 2 pi. Let's do the mins. Well, I'm going to write down the first min is 7 pi over 6. Plus, and I got to tell you, they're also going to repeat in a pattern of 2 pi k. All right. Now let's go back. I want to see if they said anything else they have to do. So it says use the first derivative test. I did that to find the minimums and maximum of f. I found where the maximum, I found the minimums are. I'm going to point out this is a trigonometric problem. And this trigonometric problem is basically going to bounce back between a top and a bottom. So these would be absolute, absolute. So these are absolute, absolute. Again, you know about trig functions. What else do I want to do? Use the first derivative test, find the minimum, maximum of f, and indicate these are absolute global. I did that. Also indicate intervals with increasing, decreasing. Oh, this is going to be more difficult. So what I'm going to do over here, I'm going to put down the decreasing interval. And what's it going to be? It's going to be tough. Pi over 6, right? And then it stops decreasing at 7 pi over 6. Hope you realize that this thing here is also going to be decreasing over there. And how does that go? Again, it's 2 pi. 2 pi k plus 2 pi k. That's decreasing. Where's it increasing? More difficult, right? Let's see, 7 pi over 6, 13 pi over 6, plus 2 pi k, plus 2 pi k. All right, let's look at our key and see how we did. I make mistakes all the time, by the way. So let's see, we have a global maximum. at pi over 6 plus 2 pi k. I got that part. Global minimum, 7 pi over 6 plus 2 pi k. I got that right. Increasing, that's over here. Let's see if I got that right. Increasing 7 pi over 6 plus 2 pi k, comma, 13 pi over 6 plus 2 pi k. I got that. And decreasing, I got this over here at pi over 6 plus 2 pi k, 7 pi over 6 plus 2 pi k. We're doing good. All those skills that you learn in Math 119, 120 are certainly paying off in your ability to do calculus fluidly. Let's do the next problem, number 5. And number 5, again, they give me the domain of it. It's greater than 0. And what am I going to do? I guess I got to do it. So what am I going to do over here? I got to put the derivative down. And that's going to be, let's see, that's going to be x squared. Bring the bottom to the top. Derivative top is 1 over x minus, well, this is going to be a tough one. Let's take a look at that. So natural log of x times the bottom, which is 1. Well, it's really not that bad. That's derivative. I'm sorry about that. X squared, 1 minus the natural log of x. All right. Now, I hope you realize that my analysis of this problem over here is going to take place in, from 0 forward. Why is that? My domain is 0 forward, and they're giving that to me. Now, is that derivative ever undefined? Not on that interval. Not on that interval. Is it ever equal to 0? Well, the natural log of e is 1, so at e. All right, at e. Now, someone says, what test point are you going to pick? I got to be careful now because I don't have a captor to do it. So I'm going to say, what's a good test point over here? I'd probably say 1 over e would be easy for me. And what's 1 over e to the minus 1? What's a good test point over here? Probably e squared. If you evaluate any number here on that interval, it's always going to be positive there. I'm worried about this. So what do you get there? If you chose e to the minus 1, you would get 1 plus 1, which is a positive number. So it's increasing. If you chose e squared, you would get 1 minus 2, which is a negative number, which is decreasing. Now, by the way, that is a clear as day absolute maximum. Let me write that down for you. So my absolute maximum, we'll check the key later, occurs at e f of e. The intervals of increasing, it increases on the interval from 0 to e, and it decreases on the interval from e to infinity. All right, let's take a look at our key and see how we did. Now it's on the next page. That's not good news for me. I got to look at it. And I'll copy, paste, so forth and so on. All right, let's take a look. Global maximum at x equals e. I got that right. F is increasing on 0 to e. I got that right. And it's decreasing on e to infinity. Geez whiz, we got that one right too. Let's go to the next question. And this one says, oh, the mean value theorem. Now, let's say you can't remember the mean value theorem. You know what? No shame in that. Go back. It's written down for you. We don't leave the notes a chance, by the way. We give you notes for a reason. We don't want to say, oh, I wasn't there that day, or I don't know where that is in the book. Well, we did this, right? So let's write this one down. I'm going to say this is continuous on the interval from 5 to 26. And what do I got to do? I got to evaluate the slope of the secant. I'll put that down for you. M secant. And what's that going to be? It's going to be f of 26. I hope that's easy to do, by the way. Minus f of 5. And the bottom would be 26 minus 5. That's the slope of the secant between those two endpoints. What's f of 26? That's going to be 5. What's f of 5? Well, 5 minus 1 is 4. Square root of 4 is 2. 26 minus 5 is 21. 5 minus 2 is 3. 3 over 21 is 1/7. Right. Their claim is this. I'll be able to find a c on the open interval between 5 and 26 such that f prime of c would equal 3 over 20. I'm sorry, not 3 over 21, 1/7. I'm sorry. I got to find that c. But before I do that, I got to find f prime. So what's f prime? Let's write this down. Y prime is going to be 1 over 2 root x minus 1. Let's write this over here. So 1/7 equals 1 over 2 root, I can't remember, c minus 1. I'm going to try to find that c now. So it's going to be, let's see, root c minus 1 equals 7/2. I'm using my skills of algebra to do that. I'm going to square both sides, and that would be c minus 1, 49/4. C equals 1 plus 49/4. C equals 53/4. I think you know what I'm going to say. Mistakes happen. So my understanding is, what's the value C that satisfies that? 53/4. Now, before I say anything, I want to claim to you, does 4 go into 53? Let me write this down for you. Sorry. 13 1/4, right? Is 13 1/4 in the interval? Of course it is. So I found a C. So what's a C? This is the C, 53/4. Did they ask for anything else? Find a point C. Oh, they said find a point. Let's write the point down now. So the point is going to be 53/4 f of 53/4. All right. Now, by the way, I think I could probably do that. And maybe I should do that. So what's the square root of 53/4 minus 1? That would be 49/4, which is 7/2. All right. That point's listed over here for you. Not so bad. All right. Let's do number 7. Theorem, one root. I'm going to do the problem differently than they're suggesting it. And the reason for that is I realize this might be a rather complicated approach to doing a rather simplistic problem. So it says, show using intermediate value. I'm not going to do that. I'm going to do it a different way. I'm going to recommend doing a different way too. I think sometimes the instructions, sometimes are overly technical. So f of x is equal to x7 plus 4x 5 plus 3x plus 5. The first thing I want to do is the interval is from -1 to 0. So what I'm going to do is I'm going to use the IVT. That's the intermediate value theorem. And the first thing I do is I just want to see what f of 0 is. What's f of 0? It's 5. Right? What does that mean? It's above the x-axis. So I'm going to say f of, what am I going to do now? -1, right? Well, I got to do this more difficult. So you get -1, -4, -3, +5, and that would give you what? -3, right? So now I know by the IVT, because f of x is continuous everywhere, and write that down, f of x is continuous everywhere. So it's certainly continuous on an interval over there. So I know there's a C now contained in the interval between -1 and 0. Whoops, I'm sorry about that. Open interval. Such that f of C would equal 0. I don't know what it is though, by the way. Don't think I can figure that out. What I'm going to show though, I want to show there's only one. This does not state there's only one. This does say there is someone. It could be 1, could be 2, could be 3. What I need to do though, is I need to get the derivative. Now the reason to get the derivative is if you can show this thing is increasing or decreasing in an interval, there's only going to be one root if I can show it's increasing or decreasing. So what do you get over here? 7x6 plus 20x4 plus 3. All right. That's not so bad, right? So what do we get over here? I want to point out, I'm looking at it, and I really have to be careful about this. And my concern about this over here is that 7x6 plus 20x4 plus 3 is always greater than 0 on any interval. How do I know that? Let me point out why I know this. If I look at this thing, let me point this out to you. No matter what number I pick for x, positive, negative for 0, this thing will always be positive for 0. No matter what number I choose over here, positive, negative, 0, this number will always be greater than or equal to 0. So I got a number greater than or equal to 0, a number always greater than or equal to 0, both of these numbers, by the way, plus 3, it's always positive. So this is really true. This is always true. Write that down. This is true for all x. So I'm going to simply say it's true for all x. Where'd you learn about inequalities? In Math 119. So what have I shown? F is increasing. F is increasing. So I want to point out what again I've done. Between -1 and 0, at -1, it was a negative number. At 0, it was a positive number. And what do I know the connection between those guys? I know it's always increasing. And what I mean by that, it never goes back down. It never goes back down. So what have I just shown? I've shown there's one root. Okay, let me go back to what they did. I'll certainly read it off to you. And what they did, I think it's not a bad idea, but you decide how you're going to do that. But it says over here, since fx continues everywhere, f of -1 equals -3 less than 0, f of 0 equals 5 greater than 0. We know by the intermediate value theorem that a root exists between -1 and 0. That is, there exists at least one seed between that open interval -1, 0, such as, and we discussed that before. Now the derivative of this thing is always positive. We discussed that. So now assume two roots. This is the part which I did not do. I'll outline what I did not do. I did not do this. And then we use Rawls' theorem. I didn't do it. I thought it was too much work. But Rawls' theorem can be shown to that, all right? Can be shown. What are we doing? We're looking for two things, two zeros. And Rawls' theorem has come up with a contradiction on that one over there. All right, here's the problem again. Let me go through this with you. Homework. Okay, there's a connection. You're at the bridge now. Are you going to cross it? I have no idea. And by the way, we're not going to force you to cross a bridge. Under no circumstance would I ever force anyone to do anything. All right, now it seems like it rather cynical, but I really do have a fundamental belief that you shouldn't force people to do things. All right. Now, by the way, someone says, well, what if that's this or that? Maybe I have pushed people around a little bit, but here's the deal. What you need to do is you need to study. What do you need to study? The examples that we've given and the lecture material that we've given to you. You need to study that. That takes time and effort. After you do that, then you do this. You need to seek if you can try these problems over here. Do we give you enough problems to try? Of course we do. Are you going to try those things? I don't know. Do you exercise? I don't know. By the way, I kind of know that when I look at people if they exercise or not. I hate to tell you this. You know that when you look at someone, and you might say that's an awful mean thing to say. That's the truth. I know when I look at someone if they've exercised. Just like people that join gyms and stuff, and you look at them, you know if they're exercising. You know that, all right? By the way, you say, what one of the key features, people exercise, they generally can do things physically that other people can't do. Exercise is an important characteristic. Is it based on age and temperament? Yes, certainly. But we do know that people are exercising. And I know that when people take exams, by the way, I know who exercises and who doesn't exercise. All right, thank you. If you need additional support for whatever reason, come by during office hours and I'd love to help you out. Am I the best source of help for you? Maybe, maybe not, but you need to get help, please. All right, we're here to help you, by the way. Thank you.